So you ready for number 5 here, Mark? This is the last one of the week. We've talked to a lot of people from Redwood City to Campbell to Pacific Grove, San Luis Obispo, building officials, contractors. I mean, this has been a lot of work.
It's been a wonderful experience, though.
We're almost done.
And the questions that people have asked have been so wonderful. And we've seen people say, thank you for sharing information I didn't know. I can make better decisions. The fire departments have been so excited about sharing the things with the community. It's just been excellent.
Our vendors are looking forward to getting home. They've been working all week with us and bringing all these new products that are helping people harden their homes. So it's been a week of learning. Let's make sure we never stop. Every day we should be learning a little bit more.
Sounds great.
Yeah, awesome.
So if you wouldn't mind coming, we're going to get started and talk a little bit about today. First of all, of course, we want to thank Hayward Lumber for putting forth the effort to make this possible. You know, the idea of creating a place in which people can come and learn about products, about opportunities, about what's going on in the industry. We all know that fire risk is a big one now, and we're making sure that we understand more about building materials and how they come together. The strategy isn't just about one material, it's about buildings and systems. So we're going to talk today a little bit about systems, the importance of realizing that it's not just one product that's rated, it's a product and whatever's behind it as well. And so we're going to talk about that. Rudy's going to explain that to you as well and what we're going to do in a minute. My name is Mark Laliberte. I've been teaching building science and building physics. This is 42 years I've been at this and travel all over the country, other parts of the world too, just to talk about how buildings work and how important it is that we appreciate that there's complexity in how buildings function. We know we have Title 24 on one hand, and we have our issues about durability, health, safety on the other hand, and we have to make sure that they all work together to also respect affordability at the same time. So we'll discuss those things as we go. Rudy, would you please introduce yourself and tell them about you?
My name is Rudy Lockhart, and I've been with Building Supply. So I'm a 40-year veteran with Hayward Lumber Company, and it's an honor to come down and talk to you from the building material supply side, what we're looking at as things are changing so rapidly. And I think as Mark has mentioned to you, looking at more than just a specific product, which are really well represented with all these vendors here, new products coming out that are meeting the current demands and needs. And one of the challenges that we're finding is that we have customers coming in, builders and architects saying, there's these products that my clients are asking for. I'd like to put this into my home. And that's fine. It's a really good, dependable product, and there's nothing wrong with it. But the challenge is that many times the entire assembly isn't being evaluated. Mark is going to be showing us some of those assemblies that are so important. And I think the best example I can come up with that is one that I ran into just a couple weeks ago. My sister lives in Santa Clarita, and she was boasting to me how attentive her neighbor was across the street because they had a contractor come in and box in all of their eaves around their house with hardy material, which is an excellent thing to do, right? The challenge is, I asked her, well, what did they do about ventilation? And she said, well, gosh, I don't know. And so sure enough, they boxed the eaves, they covered all the vents, and they didn't change the assembly. Now there's perfect applications for non-vented attics, but that has to be designed and built as a structure. So in existing homes or buildings, as we look at hardening them, we need to be taking into account how the entire structure works. As an industry, we've seen for the last 30 years as we begin improving different parts of the assembly. Right? We started out with seismic. We had earthquake challenges. We had houses coming off of foundations, and our friends at Simpson have come up with all kinds of solutions for us to make our homes and our buildings more defensible against earthquakes. And that's been wonderful. We've had thermal challenges, right, with energy shortages and things like that, where we make our homes more energy efficient. When we've done that, what is the challenge we created in many cases? Well, there's less air moving. Mark, again, will get into that, but we can solve one problem and create a new one if we're not careful. The current challenge with all the recent fires of late is how do we make our homes more defendable against fire, right? And so what we're attempting to do here today is to look at assemblies and products and hopefully learn together about ways that we can improve the hardness of our homes without compromising any of those other qualities. My part of the presentation from the building supply is looking at materials that are available from these vendors and others and say, gosh, does that really work? Now, we're not scientists. Mark's a building scientist. I'm a building material supplier. But when somebody comes in the door and says, hey, look at this new product that I got. It's really cool. It does blah, 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 blah. I say, okay, that's fine. I'm sure I believe you. And right, so I get this material in here, and there's a couple examples. Here's from our friends over here at Mata Verde, and we have from Hoover. This stuff is fire treated. It's awesome. You got to sell a lot of it and put it on because it's going to solve all your problems, right? It helps us meet current WUI requirements that we have to do, and in some cases we want to go beyond that, and we want to build better than the minimum. But we're sitting here behind the counter saying, well, does this stuff really work? It looks the same. I wonder. So a couple years ago, Mark and I were working together, and we finally decided we're going to do something about it. So we got a bottle of wine, and we're sitting in my barn and on a Coleman stove, and we're going to cook some of this stuff. We're going to see what happens, right? And so we did that. And sure enough, we amazed ourselves at some of the stuff that performed well and how current stuff performed. And so we thought, this is really cool. And so that's where this was born. I don't actually cook 5 omelets at a time when I'm camping. We made this so that we could demonstrate in a non-scientific way how these different materials will perform. It gives you a chance to see for yourself how these things do. So what I'm going to attempt to do, you'll see me working back and forth behind here. Again, it's non-scientific. The breeze is coming around, changing things, but I'm going to attempt to keep these around 500 degrees to 600 degrees Fahrenheit. And then in some cases, these two as an example are directly over the flame, and this one here. So what we have here is just number 2 common pine starter board, right? It's very likely that this is what you have on your home, on the eaves, right? Well, what is the challenge with that? Well, when the material is on the eave, you have heat coming up from a fire that comes up the wall, and it gets concentrated at that eave, just like it would under a deck. Well, that's a very vulnerable spot for combustion, right? So it's kind of important that that performs. That's why the new WUI requirements require either fire treated, as Mark is going to explain, or 2-inch. So in this case, we're going to put standard WP4 pine right on a burner at 500 degrees Fahrenheit, and we'll see how it performs. After we do that, we're going to take the same thing that's been fire treated. This one's a Hoover product, and this one here is a product, this is actually Western Cedar, and it's with a Thermex FR. Now, these folks are over here where it says Safer Wood, and they can answer all your questions far beyond where I am. Reminding, this is not a scientific experiment. All these products, to gain their performance standards, their ratings, whether it be ASTM E84 for flame spread or how long it will perform, are all done in labs in very controlled environments. The only control we have here is me and my gun and the wind. So, but it's going to be fun. We'll look at how they do. So those 3 are what we're going to cook. And then what we have here, we're going to transition to cladding. So these would be directly exposed to the flame. And then prior to yesterday, or 2 days ago, we were testing 3 different materials, or cooking 3 different materials. We had the LP flame block, which we have available in single-sided or 2-sided. And the LP flame block is an amazing product. And when I've been cooking them, they perform very, very well. It goes much beyond the other products. The challenge we have with that is it off-gases something fierce. And so I asked my wife if it was okay if I kept doing it all week, and she said, no, I really want you to be around here. So for my own health and for Mark's health and yours, we're not going to cook this one, but you're just going to have to believe me that it works very, very well. When it failed, it began cratering, and the surface material would crater, creating fissures that would allow the heat to get into the substrate, which is oriented strand board. OSB is not fire treatable. Plywood is. So, and that was the point of failure for this product. So it'll be up here, you can look at it, but I'm not going to test it for you for that reason. The next thing we're going to do is give you an illustration of what you're probably building with today. And that would be Struck 1 CDX plywood, 3/8 or 1/2 inch, right? You're probably using tons of this stuff. Our engineers love it. We put it all over our buildings. It performs very well for structural integrity. We're going to find out how it performs for fire. So to create a realistic environment, we're going to put that behind a piece of Hardy, which is an amazing product for fire resilience. And we're going to cook it at that same temperature and just see how it performs. And at what point do we have a problem with it, or do we have a problem with it? So then the next step we were going to go to, and the final in our little experiment, is going to be the same thing, but we're going to take APA rated CDX, struck 1, and we're going to fire treat it with Hoover Fire X, and we're going to see how it does. Note on the fire treating of structural panels, it does slightly reduce the structural value of it. So you always want to make sure you're working with your engineer when you're looking at substituting a product which you would think is always going to be a better product. Well, once again, we don't want to compromise one attribute for another. In almost every case I've been exposed to, there's plenty of tolerance within the spec to be able to use the fire treated. Why would that be a good reason what would be a good reason to use a product like this? Well, think about using what we would see go up all over town, which would be an assembly kind of like, oops, let me get it right here. Kind of like this, right? So we would have shear. You're going to wrap the building once with shear, right? You're going to have some kind of a some kind of a fire barrier, right? You could be using one of these here. It could be Den's glass, or you see the yellow and the green Den's glass or gypsum products going up for fire resilience, right? And then you're going to have some type of cladding over the top. In addition to a layer that I'm not including, which would be a weather barrier, right? You would put one of the weather barriers typically behind the cladding. Well, think about the labor on that. You're going around that structure 3 times to accomplish this goal. Is it possible that we could have gone with this assembly here and accomplished the same thing? Because we have our shear, we have our fire resilience, we would put our weather barrier on there in all cases, and then our cladding. Right? So those are things that we can help you with as you're looking at designing or building a structure. Is how does my labor compare to the material cost? Is this more expensive than this? Sure it is. But is it worth it for the labor savings because I'm reducing the number of trips around the building? Right? These are all great things that we can help you work through and consider. Most of the products that you're seeing represented here, we're going to talk about today, are slightly more expensive than the bare minimum required by code. But one of the factors that is changing that formula is insurance. And I don't think there's anybody here that hasn't had some exposure to insurance companies that are increasing rates, that are reducing coverage. And one of the considerations when we're building or remodeling a structure is how fire resilient is it? Because that may be what allows us to continue keeping insurance. If it's an older home, maybe bringing it up to current WUI standards would be what the insurance company would allow and say, yeah, we'll cover that structure because it's a reasonable risk, as opposed to saying, I don't know what I'm going to do. Right? So those are all the things that we're here to help you figure out. So I'm going to be here working on these burners. It's almost impossible to keep them the same, but I'm going to do my best. So you'll see me going back and forth, trying to keep a reasonably fair test and uniform temperature, while Mark is going to start working through these assemblies and showing how they all go together.
Thank you, Rudy.
Thank you, Mark.
Well, thank you all. And so as Rudy did such a great job of kind of explaining this overall building, I'm just going to share with you a perspective. When we look at buildings, we look at what we call control layers. So the first control layer is always like a thermal control layer. Secondary, we'd say a water control layer. Then we want a vapor control layer to see if things can dry effectively. I was at a house yesterday that I looked at in Avila Beach that was having terrible trouble with drying, and it would get a little bit wet. It was all trapping water. So vapor control layers. We also look at things about air control layers. You're going to notice that in California, we're trying to look at how do we build tighter enclosures. Do the tightness of the enclosure help reduce airflow, help reduce energy flow? So those things are characteristically important. We also look at the structural issues, which Rudy had brought up about structure, and that's seismic, and then the final control layer would be fire. So if we basically have those control layers, 6 control layers, there's others, but those are the primary 6. How do we make sure that I look at each layer because each one is important? Do you believe that thermal control layers in California matter? Right? And cost of energy is an issue. So you're going to see continued increases in the cost of electricity just because of the demand for electricity and the difficulty of producing it. So you watch energy go up. Title 24 was first published in 1975. So when you look at how long it's been there, it continually upgrades as that goes in place. We know that it can sometimes be frustrating to go to a rater or somebody else who's got to keep putting the pieces together to meet Title 24. The hope here is that we can find a way to meet all of those expectations. Can I make a building meet all those 6 control layers, and maybe in some cases let one control layer do multiple function. And so that's the hope that we're going to try to get to a stage as an industry that we're supporting that. Now, the last part of that that's difficult is our trade base. We know that all builders don't build houses. We have this relationship with our trades. How well can we educate the trade base to say, this is a critical function, this is important to do? How do we manage those things together as a team? How do we work with each other to say, your role is incredibly important with this other trade's role? So what we're going to do is kind of look at some assemblies here and make sure that we understand how they all go together. So I'm going to walk through this little display. And all the display really represents is different ways in which we can achieve the goals that we have, as Rudy so clearly mentioned. You can see that this is an area that, look at the top one, we see some people put in a box soffit. In a box soffit application, you'll pretend that this is actually probably going to have a vent that would allow the air to come in through here and up through this and go into the attic space as a vented attic. Now, vented attics have a purpose. What is the reason why we vent attics? What are we trying to accomplish? Basically two functions. I want to get rid of heat and then get rid of moisture. Exactly, thank you. So the idea is that as the moisture from the house and the lifestyle and occupancy drives into the attic space, the premise was if outdoor air comes in through the soffit, up through the ridge, and goes out, that's going to help dry the attic. Does that seem reasonably logical? Even in a climate like this, which can also be challenging. I've got a hot, high humidity outside coming in through soffit ventilation. The heat issue we don't really realize is probably not as significant as we used to think. Research that was done in the
Excuse me, Mark. Yeah. Hate to interrupt you, but I didn't even get them all lit yet, and we already have our first failure. You can see here the common untreated pine is supporting flame all by itself without me doing anything. So not a big surprise, right? Most of us have had a campfire or something. You put pine in there and it burns like crazy. Since we're not pyros, we're going to go ahead and put this out and we'll start playing with some other products. But first failure, here's the pine that's supporting flame all by itself.
Thanks, Rudy. So the importance of that, as you can see, this kind of application, if the air from outside, we're going to try to ventilate the attic space, this is called Vulcan vent. And that vent is basically something quite amazing. And if you look at this product, we're going to demonstrate it with that trailer there. But it's really a product that can be installed. There's a screen there that keeps the embers from getting into the attic. Ember travel is amazing. We've heard from firefighters that have said using infrared cameras, they would see the embers travel between 2 and 5 miles. Some of the traveling embers can be the size of a baseball. So imagine a tall tree, a palm, all the fern pieces flying through the air and lodging themselves in places that allow a higher wind to then ignite that fire. So this was a product that was invented where the screen doesn't let the embers in. At the same time, it's a fusible front. They'll explain it to you when they test it, but you'll see as the flames hit this, it seals this closed and locks the air from getting into the attic space. Pretty remarkable. So here I've got ventilation occurring until potentially a fire exists. This would then fuse closed. No more air could enter the attic. Now remember, after the fire is passed, the embers haven't got into the attic. This vent would have to be replaced, but it would be a small cost to replace that if it saved our attic. Remember that the two places that embers happen, they'll either come through into the attic space and light the attic itself on fire, which of course is catastrophic, or can actually potentially go through a window, land on the furniture, and create a whole nother problem, right? We can have a defensible space and suddenly the window could put us at risk. And we'll talk about that in just a little bit. So if we look at the first one, this would be a vented soffit. This is in the eaves, and I've got the Vulcan vent. Here's another application, and basically what Rudy was just testing is the idea that this is pretty common in California to use this as we've got an exposed tails, and we put this in place. This is the product that he's got there on the burners, this fire-treated one by material. And so this is an option. I've got a vent here. This is the Vulcan vent there. Some applications I could use the round button vent. We've got to make sure we still maintain all the importance of structure inside how we sheathe and make sure that we've blocked that properly. You'll also see this lower one shows a 2x6 as an untreated product because it's 2x material. It allows it to be dense enough and long enough in burn that it'll usually char first. So this is an accepted WUI product when it's in the dimensional without treatment. So that would be an option. You could actually get this treated, which would give you an extra layer of defense. Wouldn't that make good sense? If I've got a product that's at least vulnerable, I might say, I'll take the 2x and have it fire treated. You can imagine how the importance of making sure that everything lines up, whether there's a drop in that truss cord, but designing this building correctly to make sure that's in good place. I'm going to ask my young friend Patrick if you'll flip this around 180 degrees. So here's another example of what we see in attic systems, and Rudy so clearly explained how somebody had changed the way that the soffit venting worked and changed the way that the attic is going to work. The first one is pretty conventional. We look at this detail and see that as the truss sits low, very little insulation at that end, that connection joint. This ends up being a thermal problem from just that as this heats up in the summertime, it transfers energy into the space, making it a more uncomfortable. We see sometimes that the roof deck can get 150 to 180 degrees. Imagine if there's this little of insulation, that will be a conductive transfer that I can't cure. I can't cure it by blowing air conditioning on it. That's a flaw in the building assembly. How would I then fix that? Might be to raise the heel height and get that heel height high enough so thermal insulation goes all the way out to the edge, or else I do something what we're seeing more builders do, and that's called conditioning the attic. In the Title 24 and in energy codes, we're starting to see that the ductwork needs to get within the conditioned space. So what they're doing is instead of trying to get the ducts inside the house, which is very difficult, they condition the attic. So you'll see more of this where they're starting to insulate the roof deck, eliminating attic ventilation and doing this whole strategy. The challenge is that there's not very many easy ways to get that. One of the ways that's most commonly done is they'll spray open cell foam against the roof deck. When they do the open cell foam against the roof deck, that has some challenges as well. You might see that this little mock-up back here, can you guys see that? If you move over, you'll see this little mock back here. What we did is Rudy put closed cell foam in the one on the far left, open cell foam on the next one over. Then he's got a blue jean material that's got a fire treatment to it, and then of course fiberglass with a paper facing. What he did is he has a little fire starter in the base of those, and you can see what happened very quickly is the foam caught fire, created some really nasty smoke, and so he blew those out right away. So we had both the open and the closed cell foam ignited quickly. Now that doesn't mean don't use foam. It's just remember that as we use products like that, they have some risks that are associated with them as well. So protecting the eaves, protecting to make sure that the air and the embers can't get into an attic space would be important. The other one ends up being the one on the far right is just fiberglass. And the only thing that started on fire was the paper facing, which we don't really use anymore, is paper-faced fiberglass. And the fiberglass, of course, just stayed there and it was fairly inert, wasn't really affected by the fire. You'll see a company over here that's called Rockwool, and Rockwool also has a bat that's got remarkable performance characteristics. We'll talk about that in a minute. They have a bat, and their product can handle about 2,200 degrees, doesn't burn, is hydrophobic, doesn't support insects, and has no food source in it to actually grow any mold in it. So it's a pretty remarkable option as well. But remember that as we start doing this, we're going to have to take into account what happens and how we achieve that. You can see as we try to make buildings tighter in this particular application, some builders are actually putting gaskets between the living space and the conditioned attic or unconditioned attic. So there's a lot of things going on. We're watching the thermodynamics and airflow of buildings change a little bit as energy code, fire, right, and indoor air quality become part of the play. So all of this goes into how we look at buildings. Kev, if you could help me, sorry about that. If you could help me rotate this 90 degrees to this side. We're going to go there. Thank you. So as Rudy had mentioned, we also have another place to keep an eye on, right? And that would be areas like decks. And so try to imagine if the fire came underneath the deck, how quickly that could ignite a deck if we didn't do that properly. There's a firefighter who showed me a little film clip, and it was some houses had started on fire. There's a little hillside that went up the back about like this. This had a bunch of dry grasses in it. As the fire ignited the grasses, it climbed up the hill and got into the decks, the houses that were facing the other way. Within 7 minutes, 3 houses were completely on fire. So we have to be careful about decks because it's so easy for the embers in the fire to come up underneath the deck, similar to the way you saw that with the soffits. So one of the options we have with decking is to kind of look at a little bit more about how we make choices. This particular material is designed for rot and insects. So we have to make a choice. We can either do a treatment for insects and rot or do a treatment for fire. You cannot do both. So based on the deck design, you're going to say, so I'm worried about the proximity to grade. I want to make sure that the material doesn't fail. So I'm going to take something that's got more treatment for mold and rot. What I'm going to do with that is, and you can see that around the edge, you can see where it's been treated and where it hasn't been. As we do cuts, do we sometimes put a coating on the cut to make sure that that's also treated correctly? So then if you look at this, this is an example of what might happen if you had that application. This is basically a skirt that goes around that part of the building closer to the grade. It's made out of hardy, and that might help reduce the opportunity for the fire to get up underneath the deck. So you can say I made a choice for decay and rot. At the same time, I'm protecting against embers. That would be an option. On the top of the decks, I can look at things like this. This here you can see is AZEK and TimberTech, and some of the other companies here are representing products that instead of having conventional lumber, they've got products that hold up to long-term solar exposure as well as water and durability. These products then on top of a deck would start reducing the opportunity for that to ignite. Decks can also be an egress point. So that's why those are also important, not only just to start the fire, but a place I could get out. Here's the next deck you can look at, and this is where they've used the pressure-treated dimensional lumber. This is treated all the way through. You don't need to put anything on the cuts. If you cut this, it's still okay. It's run all the way through. This deck has then been built out of materials that would then allow the fire to not affect the dimensional lumber. This has got Ipe as well as a dimensional cedar or redwood, which also perform very well in the fire applications. Just as a little side note, have any of you started using a product like this where you're putting it on top of the floor joint, the joists of the deck to protect those? That used to be an area of rot. Isn't it interesting to see that as we start looking at a failure, we look for a solution, which is kind of a cool thing. So I just thought I'd let you see that piece. The last one, of course, would be things like aluminum or steel. So imagine a deck that's aluminum or steel. We have to be careful about proximity to the ocean, right? In terms of rust or corrosion. If you move the aluminum ones within a mile of the coast is what I think they had told me, it just slightly changes the warranty. On the steel side, you have to be real careful too to make sure that there wasn't any scratches or things that could allow rust to occur on steel. But in these cases, could these hold up much better than even a case like this? So you want to take a choice. What am I doing it for? Is it for durability? Is it for fire? Is it for aesthetics? And bring those all together so I make good choices. One more rotation, if you don't mind.
While you're doing that, Mark, I'd like to bring people's attention. We love learning, right? There's products that have come to our attention that we thought, gosh, this is really cool stuff. We want to bring this to everyone's, let them know about it. We don't sell stucco, but there was a product that we were made aware of. It's called U Stucco, and we thought, gosh, this thing is performing really well. We're looking for alternatives for our clients and for the public to use on their homes. And one of the attributes of this is its thermal value, how much heat is conducted through the product. So what I've been cooking here, a little bit hotter than the others, just to show you, is U Stucco, which is this one here, versus just a comparison of masonry stucco. And we're running, right now, we're running close to 200 degrees Fahrenheit is coming through the masonry stucco, and we have about 120 degrees Fahrenheit coming through the U Stucco. So who would have thought, stucco in itself is non-combustible, right? So who would have thought, gosh, we can make an improvement on stucco, right? I mean, certainly for seismic and cracking and all other qualities and attributes, but in this case where we're focused on fire resilience, not only does this particular product have other benefits, but it is a tremendous thermal insulator. So if you're having thermal challenges with Title 24 or if you're looking to make a stucco home more hardened than another, this is something you might want to consider. We don't sell it. You're welcome to come take a picture of it and go to their website. They've got some really good modeling on their website that'll show you what they do. In fact, their developer is here somewhere in our audience today just to listen to how we're representing his product. I hope we're doing it correctly. So anyway, just fun to learn. We all learn together, and a great product for you to look at. We don't sell it, but because we're not in the stucco business, but we want to know about it. Thank you, Mark. A little sidebar there.
It's quite an interesting idea. We had a guy that came to our event, and he said, do you mind if I take a piece of that? And we said, sounds good. He took a piece of conventional stucco, and he had put it in his kiln, and he got it up to about 12 to 1400 degrees, and it kind of turned to glass. and he said, can I try this piece on too? We said, sure, I don't know what to tell you. He's put in it, this is a couple days ago. He puts it in his kiln and runs it up to 2,800 degrees. He said, I couldn't get the product to get above 600. And he goes, that's as hot as my kiln would go. He pulled the thing out and it was still intact. And he said the rest of it, the stucco would have disintegrated. So he said it's quite remarkable to see that there's a product innovation, which has actually been around for quite some time. It's got thermal properties. It's got remarkable fire properties. It doesn't support mold growth. So I thought, yeah, let's show that. So that's what that product was about too. The last thing I wanted to kind of show you is sort of this evolution of how we're looking at exterior walls. We talked a little bit about the roof. We've talked a little bit about the deck, but now we got to talk a little bit about the wall systems. And Rudy sort of alluded to the idea is that when we use gypsum as an exterior material, oftentimes that's done on a more commercial building, multifamily, or the goal is to use this product to get us an additional layer of fire protection. Anytime when we look at our sheathing products, we've got to make sure that we understand that if it's structural sheathing and whatever it might be made of, is it also going to be a weather barrier? Remember I said the control layers, structural is going to be a water control layer. So when I look at my exterior sheathings, do materials like windows and penetrations, they all have a tendency to leak. So if water gets past them, what are they going to find? That's where things like weather barriers and water management layers come into play. Every building needs a water control layer on the outside of its structure. In this particular application, they showed two options. One is Tyvek, which is a really good product for looking at its ability to allow vapor to move through it. Provides a good air barrier and also provides remarkably good water protection. This is another layer of a self-adhered product, allows vapor permeability. It allows it to be self-adhered to the wall. At the same time, these dimples provide a little bit accelerated drainage. On top of that, you're going to see that as we look at wall assemblies, we've got to look at the way in which it behaves thermally. A 2x4 has an R value of basically 4. A 2x6 has an insulating value of about 6. So I'm going to put in a 2x6 wall, I'm going to put R value of 20 something in the cavity and have an R value of 6. What percentage of the wall, especially in California, do you think is solid wood that I have in the building between the inside gypsum and the outside sheathing? Anybody have a guess? 12? 30? It's about 30. So I look at 30% of my wall has an R value of 6. As I put that into a calculation, I'm going to say, you know, if I look at the overall ratio, a 2x6 wall with an R20 bat has an insulating value of about 14 as an overall value. So can we do a good job of improving performance? The only way we can change that really is to use an exterior insulation if we're using conventional framing. And you'll see exterior insulation has now become something that's really interrupting that thermal loss at that framing. This is a product called Rockwell Comfort Board 80. It's a rigid board that can be installed on the outside. Like I said, it can take about 2,200 degrees. It's remarkable in terms of thermal performance. It's hydrophobic. Water can drain through it. And we see this being used on the exterior of buildings. As I do that, you can see the window got bumped out a little bit. It's been flashed properly, integrated into the draining layer to make sure any water that gets in contact drains off the material, off the Tyvek, or off the weather-resistant barrier. Those are all characteristics that we got to keep maintaining, those 6 control layers. Now you look at one other thing is that's my window. So my window's been installed, flashed beautifully, but is the product that it's made of at all at risk in relationship to fire? If I look at the window and say, does this vinyl window under excessive heat have any potential for concern? So it could melt, it could deform just a little bit. We have to be careful, and as well as the glass. The glass can be something, as I mentioned earlier, if an ember or a piece of material hits the glass, goes through, all of the resilience I put on the outside is now at risk as an ember lands on my couch. So we have to be careful about that. It's why you'll see in the requirements under WUI, which is just, of course, the wildland-urban interface, if we look at the requirements, it says we need to use tempered glass. And I want to demonstrate a little bit of reason why we're looking at tempered glass as an option. The idea is to make sure that that glass can handle more impact. It's about 5 times the impact of conventional annealed glass. So if you wouldn't mind joining me for just a minute, would you come up here for a second? What we did is we took 2 pieces of glass. One of them is tempered glass. That would be you. Yes, you can walk. That would be appreciated. Come on up. You got it. It's okay. He loves the spotlight. And so one of the pieces is annealed glass. One of the pieces is tempered glass. And so what Rudy did, if you'd come on the back side of this, that'd be great. I'm going to ask you if you'd put on these super reliable safety glasses that should go beautifully over your conventional glasses. And Rudy had built this little display, and what it is that I don't know which one's which, to be honest with you. I just stuck him in a few hours ago. I don't remember. So what we're going to do is he's going to just hold it like this and let it go one way and let it go the other and see how it performs. Would you give that a try?
Just let it go.
Just let it go. Try it go the other way then. See how that goes. Just let it go. All right. So now I'm going to ask him just to put a little more emphasis, but not too much. Just be fair. Just give it a little throw. Sure. Sure. Amazing. What about the other way? Okay, so I think we found out which one was annealed glass, right? So this one ends up breaking in shards and allows that product to go through. You saw the effort. You all done?
Am I done?
Is it? Yeah, he's done for sure. There's nothing left. Yeah. You want to try it one more time? Try the other side. Just see if you give it one more throw. I got faith in you, buddy. So this would be tempered glass, right? So tempered glass being able to handle 5 times the impact. Go ahead. Be nice. How about that? Isn't that amazing? You go sit down. You're done. Yeah, give me those glasses back.
Oh, really?
You were awesome. It's a pleasure. Thank you, buddy. So you can see the amount of effort we put into that to try to do that. I think that if I looked at hardening my structure from fire, hardening my structure for thermal performance, making sure that the things I might use could withstand that, does that feel like we've got a building that could take on the challenges that we're seeing in whatever happens in climate? How long do you think buildings should last? What's a fair, useful service life for a home? How many? 200? How many? 100 years? I had somebody not too long ago say 25, and I'm thinking like the first mortgage would be an awesome goal, right? Don't you think? I think 100 is pretty minimal. Have any of you been in a house that was older than 100 years? And if you haven't, you need to get out a little more because they're out there, right? If you go look on the East Coast, other parts of Europe, age is something that we look at buildings and their durability. So I'd say, how about if we make choices early on at the construction phase to say, let's make this house more durable for the next however many people that might own it. And those are the choices we have to make today. It's really hard to change layers, swap out windows, realizing that all the influences of weather, climate, energy can all be put together. We also have one other concern, don't we? It's called affordability. How do I manage the cost of housing and the challenges that it faces? I want to make sure that a house can be insured, that I can afford the energy bills to operate it. So we look at these things, you'd be surprised, they're not that much more expensive. We just have to make good choices to build a more durable, more efficient structure. Does that seem reasonable? So all of us have to make sure we're doing that, not always at the cheapest product, maybe with a product that really fits that. And as Rudy mentioned so beautifully, if one product could do a few more functions, that's the optimum use of economics. So how do we make sure we do that and train everyone? What else have you seen?
Well, we've actually got some of the non-fire treated CDXs supporting flame. I didn't want to interrupt you once again because you're really on a roll there, but typically I would turn that off. I'm going to go ahead and cool them all down now, but I've been cooking these fire treated ones for pretty hot now for quite a while, and I mean, we've done this as our 5th time this week, and it just blows me away that a piece of pine, a piece of cedar, a piece of plywood, when fire treated, can perform directly on a flame, 500 to 600 degrees Fahrenheit, and it's still intact. And you'll see it's charred when you come back, and I'll cool them down so you can actually come and play with them if you want. But the natural tendency of wood is to char to protect itself, and when it's fire treated, it does even better. But you'll see that it's charred, but it didn't burn through. So if this was on your home, yeah, you might have to replace a few boards, but your home is still standing, hopefully, right? That's the goal. So if you're not impressed by this, you're a different person than me, because every time I see it, I can't believe that a piece of pine could take that kind of exposure and still be around to talk about. Same here. Look at the Western red cedar, right? It's charred, but it's still performing. If that was on your home and you had a fire burning right underneath that, your home would likely still be standing. You know, one of the strategies we have some friends here from the fire department are going to talk about is, you know, the home doesn't burn down instantly. When a fire comes through, your home may catch on fire, and then they'll typically, if the resources are there, come and put it out. Well, what we're looking for is what are materials that will give them more time to be able to defend that, and we'll defer to them on that, of course, because that's their area of expertise. In fact, while we're on that subject, you ready to roll? Let's give them what you got there.
Like that?
Yeah.
Okay. One of the things we do is defensible space evaluations and home hardening advice, and happy to see a couple of our people here that I told them about this program. But one of the The links, right? This is great. This is linking the building side to the contractor, to the client, to the fire person. And that's the chain that we kind of want to get going. So feel free to call us up if you're working with a client. This is all free work that we do. Also with our partners, Santa Barbara County and Carpinteria are here. They offer the same service, so just know where you're at, know who to call. That's basically about it. We're just super impressed with this display of home hardening stuff that you do. I think I'll end it with in the 20 or 30 years ago, it was all about defensible space, and that was removing vegetation, right? And now the pendulum has swung to home hardening. The stats are showing your survivability of your home is better if you can use some of these products around here today. Thanks.
Thank you, Mark.
What's happening in the code? What has recently happened? Because we were talking earlier about some changes that are taking place right now. Maybe you can give us.
So maybe you're talking about zone 0, right? So there's 3 or 4 different zones for defensible space. Zone 0 is what's coming out from the edge of the building out 5 feet, no material. You can either have DG or rock, no plants. I've had some discussions with people about what about putting succulents there, and I say, well, they're probably not that flammable. I'm not going to say one way or the other, but the law I think is going to take effect in 26 right now. So if you're talking to your clients, have them do that with the zone 0 to 5 feet, nothing against the house.
Thank you. And one of the important things, one of the fire marshals said, make sure that you realize that when my crew, my team comes up to a house, I want to make sure that it's safe for my team to go inside. So I want to make sure that the site, the trees have been cleared, that I can get a truck in there. I want to make sure that's important for me. He says if I go in there and I have to knock over wood piles that are stacked against the house, propane tanks that need to get removed, be very careful to look at that and say, if I want someone to save my house, I want to make sure the firemen feel welcome to get there and that there's not things that impede their ability to get there. They've got information about driveway size and the things that matter, but let's make sure that we appreciate them. I can't tell you how happy I'd be if I had my house getting at risk and one of them showed up. That's what we hope for, right? Is that would possibly happen. So I really appreciate you sharing that with us, making sure that we realize what's going on. The last thing we'd like to do is talk with the guys at Vulcan Vents. After 5 days, I'm telling you, there's just a little bit of mush in here. There always was, but now it's more.
Not like you forgot the name because you spoke about it earlier, but thank you, Mark. Hi, everybody. I'm Eric Dowdett. I'm here with New Cal Metals. We're the manufacturer of the Vulcan Vent. The Vulcan Vent is a 3-component vent. Very first part is just simple pest abatement. The second line of defense would be a 16th-inch mesh on the back that's going to protect from all the embers shooting ahead of a fire. And then the last line of defense, we have an aluminum honeycomb with an intumesic coating on it. And what we're going to display here is how that intumesic coating works. So this is a trailer with a mock-up of essentially a soffit. So you've got 2 chambers here on the front. This is what it would look like at the face of your house in the front yard as a fire actually approached. So it's approaching your home, hitting your soffit. On the right-hand side here, we have a Vulcan vent. On the left-hand side, we have a standard vent. So as that fire approaches, the radiant energy and radiant heat of that fire will make the intumescent core swell on our vent, creating a 1-hour firewall with an insulated barrier that drops the temperature from the face of the vent to the back of the vent by 1,800 degrees. So this is the vent we used yesterday in San Luis Obispo. And as that fire approaches, this vent swells shut, seals off, creates a 1-hour firewall, not allowing any flame penetration through your ventilation. We'll transition to the back side of the vent, and then you can see what it would look like in the attic of the house with that fire sitting right on the face of your home. So back here we have OSB sheeting behind 2 vents. Once again, standard vent is on the right side from this side. The Vulcan vent is on the left-hand side. So as you see, you have flame roaring through the standard vent on that side, whereas the Vulcan vent has closed, sealed off, not allowing any fire to get through it. That insulated barrier does create that large temperature drop. So what we can actually do is as we turn this trailer off and turn the fire off, he can actually get up, grab the wood from behind that vent with his bare hands. So what it's going to do is not allow any combustion behind your vent. So as we're protecting the ventilation from straight flame getting through, it's also not going to allow anything behind it to combust. So he can grab that out with his bare hands, Everybody can touch it. It's got the burn kit. Cool to the touch, just like as if it was sitting out in the sun, if that. Anybody have any questions? Yeah.
Is the vent closure permanent and requiring replacement of the vent?
It is permanent. Once the vent closes, you will have to replace it, but there would be other exposed areas that hit that high of heat that would also have to be replaced, but the studs and the main components of the home are still existing. So great question.
Thank you very much. I think that's a pretty cool display. There's just something about when I see that guy grab that panel and I'm like, uh-oh, we got a burn victim here. And he just pulls that thing out, and it's amazing how fast that occurs. So I think it's always quite a remarkable thing. So I'd like to thank you all for coming out here and thank Hayward Lumber for being so wonderful about sponsoring this. There's of course a food truck over here providing you free lunch, and I'm sure all of you guys will appreciate that. We'd love to see you spend some time with some of the vendors and just ask their questions and see what's going on, but we sure lastly appreciate. This is the 5th day of 5 days for Rudy and I, traveling up and down the coast. We started in Redwood City on Monday and finished today in Santa Barbara. And we really appreciate the interest and the care that all of us have as an industry. You know, we're a real tactile industry. That's why having things that we can actually touch and take a look at is really how we learn. So share this information. We would put out a request for just so many people to come, and the smartest people always show up. So well done. You get to pat yourself on the back for caring enough to show up. Also, please share this with others. Anybody within your team, let them know that this is important for California and for the rest of the country and for your clients. So on behalf of Hayward Lumber, Rudy Locker, just a remarkable individual I've had the pleasure to work with. And then for me, Mark Liberty, we just sure appreciate you guys all coming. If you have any questions, come on up, and thank you very much.
These two were behind Hardy, which also is an amazing product. I mean, that's right on the flame. Look how well it performed, right? And it protected that raw plywood for 45 minutes. You know, it did finally flash, and the weakest point in that is the size for spacing, right? You can't put your plywood tight when you on your roof sheathing or shear. You have to leave an 1/8 inch. Well, those gaps are what create the vulnerability for flash point on those materials. Yeah. Now it does also lose its strength. Like we can take one of these. They're too hot. I think. Let me see if I can do it this way. But it's become very brittle. But at that point, if your house had that kind of exposure, I'd be more than happy to give up my siding and re-side it than to build a whole new house, right? Yeah. So it's not strong, but look at how well that performed. There's some really good products out there, that will do the job. And again, the treating on these, I mean, these guys just blow me away. Now this is behind Hardy, but still, that sucker was hot. I was cooking it at close to 600 degrees Fahrenheit for about the last 10-15 minutes just to get some action on it.
Resilience is such a big thing, you know. It ends up being how many things will impact this house over the next 100 years. You're like, oh my, a lot. So when do you have a choice to make that change or that addition? You can't put plastic under your slab later on. You can't put this kind of weather protection later on. You got to go, I got to do those things now. Maybe I'll change the cabinets or the countertops later. But the investments in the structure, and that's the part we try to get through, is help them.
Wow. Is that amazing or what?
Dude, Joe, how are you doing, man? He's such a freaking rock star. I love these guys. We look at aluminum frame, we look at fiberglass frames, and then vinyl frames. And the vinyl ones are, of course, the most susceptible because they don't take a lot of heat before they start to sag. I really appreciate you. Thanks for coming, man. It's nice you show up. How was the tacos? Fantastic. Were they?
Oh, yeah.
Oh, I love that.